Spectral signatures like the ones I've shown here are the basis for calculation of what we call spectral indices. Spectral indices are quick and easy and useful quantities that we can calculate on the basis of a spectral signature that allows us to map a certain variable of interest. One of the first spectral indices that was developed is what's called the simple ratio. It is calculated as the reflectance in the near infrared divided by the reflectance in the red. So if we look back on our spectral signatures over here, we can see that, for example, snow has a slightly lower reflectance in near infrared than it does in red. So if we look at the calculation, that would give us a simple ratio that's slightly less than 1, say about 0.8, 0.9, something like that. Water has close to 0 reflectance in the near infrared and low but not near 0 reflectance in the red. So we would get close to 0 divided by something that's a lot larger than that. So we would get a simple ratio of around 0 for water. And if we look at vegetation, if we imagine vegetation has reflectance of 50% in the near infrared and 10 in the red, we'd get a simple ratio of 5. So that's a pretty big difference between 0 for water, let's say 1 for snow, and 5 for vegetation. And this difference is not an accident. It's because the simple ratio was designed specifically to find vegetation. Anywhere you look on a map, if you calculate the simple ratio and you see pixels that have a very high value, it's very likely because they have high density of vegetation. Nowadays, most people don't use the simple ratio. They use something called the normalized difference vegetation index. I'm just going to write NDVI. The normalized difference vegetation index is also calculated on the basis of the near infrared and the red bands. It's a difference, and the difference is the near infrared minus the red reflectance. And that difference is normalized by the sum of the near infrared and the red reflectances. NDVI has a couple of characteristics that make it preferable to the simple ratio. For example, if you have 0 reflectance in the red, the simple ratio calculation is going to give you an error because you cannot divide by 0. That's not a problem with NDVI. If you have very low red reflectances, the simple ratio can give you extremely high values that are difficult to deal with. NDVI, on the other hand, because of the way it's calculated, its value ranges from 1 as a maximum to -1 as a minimum. So that's a nicely bounded range. You'll typically get values of around 0.7, 0.8, maybe even 0.9 for very dense, healthy vegetation. Think of the Amazon rainforest. And you'll get values down to maybe 0.2, 0.3 for less dense, less healthy vegetation. Water, because it has lower reflectance in the near infrared than in the red, it'll tend to get negative values, negative 0.2, 0.3. You can imagine what snow will get. Near infrared minus red reflectances are going to be close to 0 because the reflectance curve is pretty flat in that region. So we'll get an NDVI close to 0. So NDVI works in the same way as the simple ratio. You get high values whenever you have vegetation, and you have lower values whenever you get less vegetation. And that can mean less healthy vegetation, less dense vegetation, or unfortunately it can also mean vegetation mixed with other things that have very low NDVI values, such as water. So wetlands, for example, even if they have very dense and healthy vegetation, the water will tend to drag their NDVI values down. The advantage of these kinds of spectral indices is that they're easy to calculate, they're rather informative, and you can quickly display them on a map to get a quick sense of what is where. The downside is that they're not directly related to any individual characteristic of what you're looking at. So it can be hard to look at an NDVI value, for example, and estimate the amount of biomass in an area on that basis. So advantages and disadvantages aside, vegetation indices especially, but all kinds of other spectral indices that can be used to quantify water, mud, snow, ice, build-up areas, they're very used in the remote sensing world because of their ease of use.